Welcome to This Explainer. Today, we're embarking on a bit of a journey to unlock some pretty serious hidden superpowers inside the devices you use literally every single day. Look, if you've ever felt like your computer or your phone is kind of keeping secrets from you, well, you're absolutely right. They are. So today, we're going to bypass all those flashy graphics and get right down to the core of how our machines actually think.
I want you to just let this thought sink in for a second. Most people use 10% of their phone's power because they only click colorful buttons. Today, we break past the screen and talk directly to the operating system. You can consider this a massive wake-up call. We are all so conditioned to interact with our tech through this comfortable, highly curated layer of illusions. But if you truly want to master your tech, we have to shatter that illusion and step into the reality of the command line.
All right, Section 1, the graphic illusion versus the command line reality. Okay, so let's break this down. The GUI, or graphical user interface, is exactly what you're used to. It's this comfortable, kind of bloated illusion designed basically for everyday consumers. It translates complex operating system tasks into these friendly visual metaphors. But think about it. Your computer is wasting incredibly valuable GPU and CPU processing power just to render, a 3D trash can, or bouncy animations and transparent windows. On the flip side, we have the CLI, the command line interface. This is the raw, lightning-fast reality. It completely bypasses that heavy visual rendering engine. It communicates purely via standard input and standard output. And because it's just text, it's so lightweight it can run on super weak hardware, massive server racks that don't even have monitors attached, or, as we'll see, right inside your smartphone. Moving on to Section 2, understanding your tools, terminal versus shell. So before we can actually wield this kind of power, we have to clear up what is probably the biggest beginner confusion out there. We need to separate the window from the engine itself. A terminal emulator. It is literally just that visual window wrapper. It's simply the environment that captures your keystrokes and displays the text pixels back to you on the screen. Think of GNOME Terminal on Linux, CMD on Windows, or apps like Termux and Alacrity. The terminal itself doesn't actually process a single command you type. It's just the messenger. The shell, on the other hand, well, that's the brain of the operation. This is the actual programming language environment running securely inside that terminal window. It acts as the interpreter. When you type a command and hit enter, it's the shell that wakes up, checks its internal paths to see if it recognizes the program, does all the heavy lifting, and then just hands the result back to the terminal to show you. When you actually map out this exact architecture, it becomes super clear why this separation is so vital. The terminal is just this thin outer layer grabbing your keystrokes, while the shell is sitting securely inside, doing all the real processing and execution. And grasping this concept is a real game changer, because it means we aren't just memorizing random commands anymore. We're actually understanding the anatomy of the machine. So, what shells are you going to be using on this journey? Well, there are three major heavy hitters. First is SH, the Bourne shell. This is the ancient, original Unix shell, basically the granddaddy of them all. Then you've got Bash, or the Born Again shell, which is the standard, absolute workhorse default for most Linux distributions. And finally, ZSH, the Z shell. This one is highly customizable and has actually become the modern default on Mac operating systems. Which brings us to Section 3, navigating the realm, the root tree. Now that we have our tools sorted, let's talk about the actual physics of this new world. If you're coming from a Windows PC, you are totally used to separate drives, right? The C drive, the D drive, maybe a USB thumb drive that pops up as E. Well, in the Unix and Linux architecture, that concept doesn't even exist. Instead, we have the root directory, which is represented by a single /. It is one massive unified tree. Every single thing on your system, external drives, network devices, system configs, it all lives as a branch growing out of this single unified root. So picture this. You drop into a command line and nothing. You have zero visual cues. There are no folders to look at. You are totally flying blind. So how do you even move around? You use a command like pwd, which stands for print working directory. It queries the system and spits out your exact absolute path relative to that root /. Then you use cd, or change directory, to actually travel. You can type an absolute path to teleport literally anywhere instantly, or use handy relative shortcuts like cd ... to back up one parent folder, or cd/home to just instantly snap back to your home base. Okay, so you've navigated into a directory, but you need to see what's actually hiding in there. Enter the ls command, short for list storage. But the real magic here is in the flags. If you just type ls, you get the basic names. Boring. But ls-l? That reveals the long format. We're talking hidden permissions governing who can read or write the file, exact byte sizes, and timestamps down to the actual minute. And if you throw in ls-a, it reveals all files. This uncovers system files that start with a dot, like .bashrc. These are deliberately hidden from normal view just to protect them from average users messing things up. All right, Section 4, the power of creation and destruction. Seeing the system is one thing, but altering it? That's a whole different ballgame. Suddenly, you realize you have the power to just conjure structures out of thin air. With mkdir/p, you don't just make a single folder. You command the system to instantly build entire nested chains of folders inside folders with one keystroke. And with the touch command, you can generate perfectly blank documents instantly, ready to be coded. Honestly, it's a lot like digital alchemy. But with the power of creation comes the absolute power of destruction. It is absolutely crucial to understand the RM, or remove command. Remember earlier how we talked about the GUI illusion? The recycle bin is a huge part of that illusion. It's a cushy little safety net. The terminal, it has no safety net. It operates with absolute finality. When you execute RM, the operating system immediately unlinks the file pointer from the physical storage drive. It is gone, like instantly. Which brings us to, without a doubt, the most dangerous command in tech, rm-rf/. I want to slow down here for a second because this is wild. RM is remove. The -r flag means recursive, meaning delete a folder and absolutely everything nestled inside of it. The -f means force, as in don't ask me for permission, just do it. And that /, as we learned, is the root directory of everything. So this command tells the computer to forcefully, completely, and mercilessly delete the entire operating system, starting from the roots until the whole machine just completely crashes. Let's step back from the edge of destruction for a minute. Section 5, Achieving Mastery, Automation Superpowers. A true power user doesn't just run one command at a time. They chain them together to multiply their effectiveness. And there are two distinct ways to do this. The double ampersand acts as a logical and sequence. It means the second command in your chain will only run if the first one succeeds without any errors. It's safe, it's conditional. Compare that to the semicolon. That is just brute force execution. It tells the shell, hey, run the first command and then immediately run the second, regardless of whether the first one succeeded, failed, or completely crashed. And that leads us to, honestly, one of the most elegant concepts in all of computing, pipelines. Represented by the vertical bar or the pipe symbol. A pipeline takes the standard text output of the command on its left, and rather than just printing it out to your screen, it funnels it directly as the input for the command on its right. It acts like a conduit. This means you can combine 3 or 4 incredibly simple commands to perform vastly complex, instant operations. Imagine dumping a server log of, say, 10,000 users and just piping it straight into a search command to instantly find one specific IP address. It's brilliant. Finally, Section 6, the real-world reveal, mobile Linux engines. I really want to bring this entire journey full circle with a pretty massive realization. We spend thousands of dollars on fancy laptops, but the crazy reality is, if you have an Android device in your pocket, it is built directly on top of the Linux kernel. You are literally walking around with the foundational plumbing of a powerful workstation in your pocket right now. And by using an app like Termux, which again acts as a terminal emulator, you can unlock this raw engine immediately. No rooting, no hacking your phone required. Through that terminal emulator on your phone, you get access to package managers like PKG or APT. Just like an app store has a visual interface for everyday consumers, a package manager is how developers install software. By simply typing pkg install Python, your phone's shell reaches out to global online repositories, downloads the raw Python binaries, and configures all the system paths automatically. Within seconds, you are running full, complex programming scripts directly from the smartphone in the palm of your hand. It is genuinely awe-inspiring when you think about it. We started this explainer talking about the illusion of the GUI and how most people only ever utilize 10% of their device's true capabilities. But by stripping away that visual bloat, understanding the shell, mastering the root tree, and leveraging command pipelines, you've breached the surface. Your pocket literally holds a full Linux workstation. The tools are already there, just waiting in the dark. So the only question left for us is, what are you going to build with your 90%?